Hello again, Internet peoples. Please note this is a re-release of a video from my old channel, A Digital Mind. Recently came across a game called Islanders. It's a fantastic little city building game that is stress-free, really relaxing, really quite addictive game. As you can see on screen, it's about islands, and on these islands that are randomly generated, we can place a selection of buildings to score points. If we place them in particularly strategic positions. Ever such a nice little game, and believe it or not, it's a second release by the company called Grizzly Games. I came across Grizzly Games, or more specifically Islanders, that's produced by Grizzly Games, through a YouTube channel run by Jonas Tyrollers. Apologies there, Jonas, if I said your name incorrectly. Jonas is a YouTuber who started up his channel about a year and a half ago, and he's talking about his journey into using Unity and Game Maker and various other game engines to actually produce games as an indie developer. And he talks about his concerns of the journey and the actual things he's achieved during the journey. Quite an enthusiastic individual and quite informative. And he recently promoted this as it was only released on the 4th of April in 2019. And I've been playing it now for a few days, and I really quite like the game. But on playing the game, I thought to myself, well, these mechanics, I could produce some of these myself in Unity. So here I am, making this video, after working out one of the simple mechanics of the game. I'm not sure if it's the same as what Jonas did, but it seems to work in a very similar way. The mechanic I'm talking about is the mechanic that allows the buildings to track the mouse and float above the ground plane that you can place it on. It also detects where you can't place it. For example, when you go onto the edge of a rock face, it changes the colour of the building object to red to indicate that you can't place it there, and it won't allow you to place it there. But for now, this video is going to cover the simple mechanic of tracking the mouse and positioning it on the actual plane itself. So let's crack on. Okay, here we are in Unity. The first thing we need to actually do is set up our scene. So to get the scene set up, let's start off by making the surface on which we're going to place our objects. So for that purpose, we're just going to use a very simple plane. We'll just make sure that this is actually central within our 3D world by resetting its transform. So occasionally they open up in the wrong place, and that gives us our initial surface for this prototype. Our next step is to actually create the object that we're going to place in our world. We're going to make a simple cube here for that purpose, but you could use a mesh or one of the other options within Unity, but we're just going to use a simple cube. Let's reset its transform, ensure it's central in our world. And you'll also notice that actually in our game view we can barely see that cube, so I think we need to assign a material to it. Let's create a new material, and let's call that red, and surprisingly let's make it red. And we'll just assign that onto our cube. There you go, and now the cube nicely jumps out within our actual game view. So, onto the actual game manager itself now. We need to create ourselves an empty object, and let's just call that game manager. Now the purpose of this game manager is to actually track the mouse and move objects on screen accordingly. Typically have it in most games, some kind of game manager for controlling the actual flow of the game. And that game manager is going to need a script, so a new script, and we're going to call that Game Manager also. Okay, so now we have our scene set up, or the basics of our scene, and we have a script ready to start our code in. So let's go ahead and actually open up our script and transition over into Visual Studio itself. So as we have a game object on screen already that we're going to be using for tracking around with our mouse, we need to make some kind of link to that game object. For that purpose, we will create a public GameObject variable, and in this instance I'm going to call it the cube, but you can call it whatever you want as long as it's consistent throughout your code. This is just to make it nice and simple and easy to follow. So if we now build that script and transition back over into Unity itself, we should be able to see that against our Game Manager object, we now see the cube variable that we just created, and we can assign our cube object to that. And now we have a nice link between our code and the 3D world itself that we can see on screen. Moving back over to Visual Studio, we now need to find a way to use that code. We're going to do this on the update. As we're not using physics here as such, well, we will be doing, but not physics and moving objects using the physics engine within the 3D environment. We're going to use a simple update, which can update at any time. And to actually work out where we need to position our cube, we're going to actually have to use a ray. A particular ray we're going to use is one that casts from our camera and the position of the mouse within our camera view straight out into our scene. And what that will do is report back, when requested, anything that it hits in the scene and the particular position it hits at. And therefore we will then get a position in 3D space to subsequently place our cube. So let's start off by creating a ray variable and calling a method within our camera, in this case the main camera, called ScreenPointToRay. So in other words, a point on our screen, cast a ray from that outwards into the 3D view. And the point we're going to use, as you can see here, it's asking for a vector 3 position. We're actually going to use our mouse input for this. So input.mouse position. And from that place, it will then create a ray casting out into our 3D world. And of course, when we hit something, we've got to have somewhere to store what it hits. So we're going to use a Raycasthit and simply call that hit. So we now have the variables and a method for casting the ray. But what we haven't got is anything for checking that and actually using those two variables. So for that purpose, for checking, we're going to use an if statement, and we're going to call on our physics engine to actually do a raycast using the ray that we've just created, outputting into hit. So if there's anything actually hit, it will then move into the next line of code, which I'm going to type now. Now, as I said before, we want to move our cube to the position that the ray hits within 3D space. So it hits a collider within the 3D space, which our plane does have, as does our cube. It will then move the cube to that position in 3D space. So what we need to do is change the cube's transform position. So let's do that. The cube transform position. And what do we need to change it to? We need to change it to the hit dot and the point where it hits. And there you go. That's some very simple code, and it will actually now move our cube to where we want it. So let's build the solution and transition back into Unity and hit our play button. And our mouse at the top of the screen here is not hitting anything, and as we move down onto the plane, we will see that the cube moves to that position. But we seem to have a problem. So what is happening here is quite simple really. We're casting an array from our camera out into 3D space. It is hitting an object, reporting where it's hit, and then our cube moves to that position. Our cube is also an object in 3D space. So it is hitting the surface of the cube, moving the cube to that new position, then hitting it again and moving it again, and repeat. And that what makes the actual object seem to zoom into the screen until it actually goes behind the camera, at which point it resets back to the position on the plane. As you can see here, now I move my mouse cursor off the plane, you can actually see the cube has gone level with the camera or behind the camera viewport. So you can't see it on screen, but it's actually in 3D space behind the camera. And when we click back on the screen, it shoots forward again. So we need to fix that, and that's quite a simple fix really. What we have to do is tell our Ray that it only detects certain objects. And to do that, we use a function of Unity called a layer. So our first step is to add a new layer to place the plane into. So let's click on the plane. We look in the inspector, we have a layer. Currently the plane is in the default layer. We're going to add a new layer called ground. Go back to our plane, assign it to ground. Now that plane is within ground. But how do we use that? So let's transition back into Visual Studio. First thing we need to do is create a link to that particular layer. And for that we will use a LayerMask, so a public LayerMask. And we're going to call that, for simplicity, just call it ground layer. Okay. And the Raycast method in the physics engine is overloaded with several variants. And one of those variants takes a LayerMask, and it also takes a distance. So hit comma here. As we can see, we have a ray, a maximum distance for that ray, and we have a LayerMask. So let's make the maximum distance 100 units, so i.e. cast the ray 100 units out from the camera, and only detect objects that are in the ground layer LayerMask that we will specify. So now when that ray hits something that is within that layer that we're going to specify for ground layer, it will then and only then return a hit. And from that we can move the position of the cube. Let's go back into Unity, and the first thing here is that we need to assign the object, the layer object that we've just created, a layer. But I haven't rebuilt the code, so let's transition back again and quickly rebuild the code. And when we go back to Unity, we will then see that now we have the ground layer LayerMask, and we can select the ground layer. Now running the code, we'll now see that when we move our mouse around and we touch the plane which is in the ground layer, it will move and only move to the position that we're pointing at. There is a bit of a problem here, as you can see. As I come to the edge of that plane, we can hang over it, and it also sits through the plane, that the cube sits through the plane. That's to do with the anchor on the cube itself, and we'll be looking at in the next video. Apologies for the inconsistent sound during this video, as it is a re-release of an old video I produced using old equipment. Thank you for watching.